Welcome to day 36 of our course on object-oriented programming. In today's lesson, we will be diving into unit testing using Python's built-in framework, Unit Test. Today, we will cover key concepts in testing, including why it's important and how to write effective test cases. Before we begin, let's understand what testing is. Testing ensures that software works as expected. There are several types of testing in software development. Unit testing, which tests individual functions. Integration testing, which focuses on how different components work together. System testing, which tests the entire application. And finally, acceptance testing, which verifies that the software meets business requirements. Testing is crucial for several reasons. It helps identify bugs early in the development process, ensuring that the code behaves as expected. It also helps maintain code quality, especially when refactoring, and ensures the long-term stability and reliability of the software. Unit testing provides numerous benefits. It allows you to catch bugs early before they become big issues. It ensures that individual parts of your code are working as expected, which is key for long-term software quality. Unit tests also make it easier to refactor your code, knowing that any breakages will be immediately flagged. In Python, we use the unit test framework for writing unit tests. The basic structure of a test case is to subclass unit test, test case, and define methods that start with a word test. These methods contain assertions that check whether the code works as expected. Let's look at a simple example. We have a function add a comma b that adds the sum of two numbers, that returns the sum of two numbers. We write a test case in a class that subclasses unit test. Test case. The test add method contains assertions like self.assert equal add 1, 2, 3, which checks if the result of add 1, 2 is indeed 3. Unit test provides several built-in assertions to check conditions. Assert equal a comma b checks if a equals b. There's also assert not equal a comma b to check if two values are not equal. Assert true x and assert false x to check boolean values, and assert raises to ensure that a certain exception is raised during execution. Writing test cases. When writing test cases, it's important to ensure that they are clear, independent, and focused on one specific aspect of the function. Method names should describe the test purpose clearly, like test addition of two numbers, so anyone reviewing the code can easily understand the test's intent. Here's another example. Consider a function subtract a comma b that returns the difference between two numbers. The test subtract method contains several test cases, including subtraction, subtracting positive numbers, negative numbers, and edge cases like subtracting 0 from 0. To run your unit tests, simply use the following commands in your terminal. Python -m unit test module.py. This will execute the tests defined in test module.py and provide you with a report on the success or failure of each test. There are several best practices to keep in mind. One is test-driven development, where you write tests before writing the actual code. Tests should be independent of each other to avoid dependencies. Additionally, mocking is a technique used to simulate parts of the system that are not the focus of the test, ensuring that tests are isolated. Now it's time for some hands-on practice. Your first task is to write test cases for a function that checks if a number is prime. The function should called the function should be called isPrimeN. Be sure to test edge cases like 0, 1 and negative numbers, as well as prime and non-prime numbers. For the second task, write test cases for a function reverse string s. This function should reverse the given string. Test cases should cover scenarios like empty strings, single character strings, and multi-character strings. To summarize, today we covered the basics of unit testing, the importance of writing tests, and how to use Python's unit test framework. We also looked at common assertions and best practices. Remember, testing is an ongoing process, and writing effective tests ensures your code is robust and maintainable. Before we conclude, here are some additional resources for you to explore. The official Python unit test documentation is a great place to start, and if you are interested in test-driven development, the book Test-Driven Development by Kent Beck is highly recommended. You can also explore other testing frameworks like PyTest and Nose for more advanced testing techniques. Welcome to day 37, Debugging Techniques in Python. In this session, we will explore essential debugging tools and strategies that will help you identify and resolve issues in your Python code effectively. First, let's understand the types of errors you might encounter in Python. There are three main categories. Syntax errors. These occur when there's an issue with the code structure like missing parentheses or incorrect indentation. Runtime errors. These happen during execution, such as trying to divide by 0 or accessing an invalid index. Logic errors. These are tricky because the program runs but produces incorrect results. These errors often require deeper investigation. Effective debugging starts with understanding how to troubleshoot common issues. You can use print statements to track variable values and the flow of your program. Define the problem area by narrowing down the issue to a specific part of the code, commenting out sections if needed. Simplify the code to isolate the error. And finally, read tracebacks carefully. When an error occurs, Python provides a traceback with information about where the error happened, which helps you locate the issue. Let's dive into using PDB, Python's built-in debugger. You can set breakpoints in your code using the import pdb.setTrace statement. This will pause the program at that point, allowing you to interactively inspect variables and step through the code to track down bugs. When you are using PDB, there are several commands you can use to navigate through your code. N stands for N next, execute the next line within the current function. S step into a function called to debug it. C continue. Resume the program until the next breakpoint. P expression. Print the value of an expression. Q quit. Exit the debugger when you are done. Here's an example of using PDB in a function that divides two numbers. Notice the pdb.traceback call. When the program reaches this point, it will pause and you can inspect the variables a and b and step through the code line by line. Moving beyond the basics, you can also use IDE debuggers for a more visual debugging experience. Popular IDEs like PyCharm and VS Code allow you to set breakpoints, step through your code, and inspect variables with ease. Another valuable tool is logging. Using Python's logging module, you can keep track of program behavior over time, making it easier to identify and debug issues later. Here's an example of how to use the logging module. Instead of using print statements, logging provides a more flexible solution. With logging, you can log messages of different severity levels such as debug, info, warning, error, and critical. Unit testing is another powerful technique for debugging. By writing tests for individual functions, you can catch bugs early, ensuring code works as expected. Unit tests also help isolate errors and they ensure that future changes to the code do not introduce new bugs. Now it's time to practice. Here are three exercises to help you refine your debugging skills. Write a division function that handles division by zero and use PDB to debug the exception. Create a script with a logic error and use PDB to find and fix it. Implement logging in a small banking system program. Introduce an error and debug it using logs and breakpoints. To summarize, debugging is an essential skill for any developer. Use print statements, PDB, and logging to troubleshoot effectively. Leverage advanced tools like IDE debuggers for a more visual experience. And remember, unit testing is a great way to catch bugs early. By practicing these techniques, you will become a more efficient and confident debugger. Welcome to day 38 of our object-oriented programming course. Today we will be diving into the concept of multi-threading, learning about threading, its benefits and best practices. Let's get started. Multi-threading allows a program to perform multiple tasks concurrently within a single process. Threads are the smallest unit of execution and share the same memory space, making communication between them more efficient. This approach helps improve CPU usage, especially when performing IO-bound tasks, and is perfect for tasks that can run in parallel without interfering with each other. Let's take a quick look at the differences between threads and processes. Threads are lightweight units of execution within a process, sharing the same memory space. On the other hand, processes are independent programs, each with its own memory space. Threads are generally more efficient than processes because of their ability to share resources quickly, but they come with their own challenges. Python makes multithreading simple with the threading module. This module allows you to create and manage threads in your program. For example, here we define a simple thread that prints numbers from 1 to 5. We create a thread using the thread method, start it with start, and use join to ensure the main thread waits for the new thread to finish before continuing. Synchronization is crucial when multiple threads access shared resources. Without it, you risk data inconsistency. Locks, also known as mutex, help prevent this by ensuring that only one thread can access a resource at a time. In the example here, we use a log to ensure that both threads print numbers safely without interference. Now let's talk about deadlocks. A deadlock happens when two or more threads are waiting for each other to release resources, causing the program to come to a halt. To prevent deadlocks, we should lock resources in a consistent order and use timeouts to avoid threads getting stuck indef- indefinitely. Managing a large number of threads can be inefficient. Instead of creating new threads every time, Python offers thread pooling with the thread pool executor. By defining a pool of threads, you can easily distribute tasks to available threads, improving the efficiency of your program. The example here demonstrates how to use thread pool executor to run tasks concurrently. When working with multithreading, be aware of common issues like the Global Interpreter Lock or GIL, which can limit Python's ability to execute CPU-bound tasks in parallel. Another common issue is race conditions, which occur when multiple threads try to access shared data at the same time. The best way to handle this is by using locks or other synchronization mechanisms. To work efficiently with multithreading, keep a few best practices in mind. Minimize shared resources to avoid the need for complex synchronization. Use synchronization mechanisms like locks to prevent data corruption. Optimize with thread pooling to avoid the overhead of creating too many threads. Finally, always profile and test your code to ensure performance is not being compromised. Now let's put what we have learned into practice with a hands-on activity. Your task is to create a multi-threaded program that fetches data from multiple URLs concurrently. Use synchronization with logs to manage shared resources and then optimize your program with thread pool executor to handle a large number of tasks efficiently. Welcome to day 39, working with asynchronous programming. In this session, we will dive into the concepts of asynchronous programming in Python using async, sure, async, and await. Let's explore how these tools can help us manage concurrent tasks efficiently. To start, let's understand what asynchronous programming is. Asynchronous programming allows multiple tasks to run concurrently without blocking the main program flow. This is particularly useful for IO-bound tasks such as making web requests or reading and writing files, but the program does not need to wait for one task to finish before starting the next. Now, how does Python's async show module make this happen? It uses an event loop to manage and schedule asynchronous tasks. By using async and await, Python allows us to write asynchronous code without manually handling threads or processes. Let's see how this works. Here are some core concepts in async that we need to understand. First, coroutines. These are functions defined with the async-def syntax. Coroutines can pause their execution using the await keyword and resume once the awaited task is completed. Next, tasks. A task is essentially a coroutine that has been wrapped in a way that allows it to run concurrently with other tasks. Finally, the event loop. The event loop runs in the background and schedules these tasks. It allows one task to execute while another is waiting for something, like IO operation to finish. Let's look at a simple example of how Essentio works. In this example, we have two tasks, task 1 and task 2. Both tasks start running concurrently. Notice how we use await Essentio.sleep to simulate an I/O operation. This non-blocking operation allows task 1 to run while task 2 waits for 1 second before finishing. Meanwhile, task 1 continues its execution and completes after 2 seconds. When we use essentio.gather, both tasks are executed concurrently. This ensures we don't waste time waiting for one task to finish before starting the other. Now let's break down the async and await keywords. The async keyword is used to define a coroutine. It tells Python that the function is asynchronous and will contain await expressions. Inside these coroutines, you can use the await keyword to pause the execution and wait for another asynchronous operation to complete, such as I/O or time delay. In this way, async and await allow us to manage concurrency in a very intuitive way. Let's apply this to a practical example, building a simple web scraper. In this code, we use the AIO HTTP library to make non-blocking HTTP requests. Each URL is fetched concurrently using essentio.gather. By using asynchronous programming, we avoid waiting for each request to finish one by one, making the scraper much more efficient when dealing with multiple URLs. Now let's talk about error handling in asynchronous programs. Just like in regular Python functions, we can use try and catch blocks inside coroutines to catch exceptions. If an error occurs while one task is running, it will be caught by the except block. However, remember that uncaught exceptions will propagate to the event loop and may stop other tasks from executing. Asynchronous programming is not only for web scraping, it's widely used in real-time applications such as chat applications or multiplayer games, where multiple users interact with the system at the same time. Web scraping, where we make multiple non-blocking requests to gather large datasets quickly. IO-bound tasks like downloading files or interacting with databases where asynchronous programming can significantly improve performance by not blocking the main program. To recap, Asyncio helps us manage concurrency in Python by using coroutines and an event loop. Coroutines are defined with async def and we use await to pause execution until another task completes. Asynchronous programming is ideal for I/O bound tasks where it helps us handle multiple tasks concurrently without blocking. This approach allows us to write more efficient, responsive and scalable programs, especially when dealing with tasks that involve waiting such as network operations or file I/O. This concludes our session on asynchronous programming. I hope you now have a clearer understanding of how to use asyncio, async, and await to write concurrent programs in Python. Keep practicing and you will be able to apply these concepts in real-world applications. Welcome to day 40 of our Python course. In this session, we will dive into web development with Flask, a lightweight framework in Python. The objective is to learn how to build a simple web application using Flask. We will cover the basics including routing, template rendering, and handling forms. Let's start with an introduction to Flask. Flask is a microwave framework for Python which is lightweight and easy to use. Unlike Django, which is a full-fledged web framework, Flask gives you more control and flexibility to add only the components you need, making it great for small to medium-sized web applications and APIs. Now let's see how to install Flask and set up a basic project. You can install Flask using pip by typing pip install Flask in your terminal. Once installed, we will create a simple project structure. You will have a app.py file for your main code, a templates folder for your HTML files, and a static folder for CSS and JavaScript. To create a basic Flask application, you need to import Flask and render template. The app is initialized with Flask name. The @app.router decorator defines the URL path, and in this case, it's the home page which renders an index.html template. Finally, we use app.run debug equals to true to start the server, enabling debugging for easier development. Flask uses routing to map URL paths to functions. In this example, we have defined a route for the About page. Additionally, Flask allows dynamic routing. We can pass parameters like username in the URL, and Flask will render the corresponding content like greeting a user with their name. Flask allows you to handle user input via HTML forms. Here's an example of a simple form where the user enters their username. We use the post method to send the data to the server, and in Flask, we access the form data using request.form. Once the form is submitted, we can delete the user by their name. Flask uses Jinja 2, a powerful templating engine, to render dynamic content. In our template, we can pass variables like name from Python to the HTML. For example, when visiting a URL like /greet/John, Flask will render a greeting saying "Hello John" by substituting the placeholder name with the actual value. Static files like images, CSS, and JavaScript can be served from the static folder. In this example, we are linking a CSS file using the URL for function to ensure that Flask properly serves the static file. This allows us to style our web pages with custom CSS. To run the Flask app, we use the command python app.py in the terminal. This starts the Flask development server, and you can access your web application in the browser at http 127.0.0.1:5000. Flask will automatically reload the server when you make changes, which is great for development. For your practice, I suggest building a simple to-do list application using Flask. In this mini project, you will create functionality to add, view, and delete tasks. You will work with forms for user input and dynamically render the tasks using templates, helping reinforce the concepts we have learned so far. As we conclude, here are some advanced topics to explore. Once you are comfortable with Flask basics, you can dive into more complex features like session handling for storing user data, implementing user authentication, and even deploying your Flask application to a production server. These will take your web development skills to the next level. Welcome to today's session on working with Django. In this presentation, we will introduce you to Django, a powerful Python web framework, and guide you through creating a basic web application. Let's start with an overview of Django. Django is a high-level Python web framework that promotes rapid development and clean, pragmatic design. It comes with several key features that make it easy to build powerful web applications, including a built-in admin interface, automatic database migrations, and strong security features such as protection against SQL injection and cross-site scripting. It's it's also highly scalable and offers reusable components for better code management. Django follows the model view template or MVT architecture. In this pattern, the model is responsible for the data structure, essentially mapping to your database tables. The view contains the logic that dictates how the data is presented, and the template is the actual HTML file that displays the data to users. Django also features URL conf, which maps URLs to views, and a built-in admin interface that helps manage application effortlessly. To set up a Django project, first install Django using pip with the command pip install Django. Once installed, you can create a new project by running Django admin start project my project. This will set up the basic structure for your project, which includes directories for settings, URLs, and applications. After setting up your project, you can run the development server using the command python manage.py run server. This will start a local server on your machine, which you can access by visiting http 127.0.0.1:8000 in your web browser. This allows you to see your Django app in action. Now let's create an app within our Django project. An app is a smaller functional module that you can use across different projects. To create an app, run the command python manage.py start app my app. This will generate the necessary files for your app, including models, views, and URLs. In Django, views define the logic behind rendering data. For example, a simple view might render a template when a user visits a certain URL. Templates are HTML files that contain the structure of your page. For instance, the home.html template might display a welcome message to users. Views and templates work together to create dynamic web pages. URL routing in Django maps URLs to specific views. For instance, you can define a path in the urls.py file like path views.home, which will link the root URL to the home view. This ensures that users are directed to the right view when they access a particular URL. Models in Django represent your data. For example, you might define a post model to store blog posts. Models are created using Django's Object Relational Mapping or ORM, which automatically translates Python code into database queries. Once you create a model, you can apply migrations to update your database structure. One of the most powerful features of Django is its built-in admin interface. By enabling the Django admin in your settings, you can manage your data easily. You can create a super user to access the admin interface by running python manage.py creates create super user. Once logged in, you can add, edit, and delete data directly from the browser. As a mini project, let's consider building a simple blog application. You will define a post model, create views to display and add posts, and configure URL routing to navigate between pages. Additionally, you will use Django's admin interface to manage the posts you create. To recap, Django simplifies web development by providing a built-in admin interface, security features, and a clean architectural pattern. With its model view template structure, Django enables efficient code organization. I encourage you to dive deeper into Django's forms, authentication, and more advanced features to take your web development skills to the next level. Welcome to day 42 of our course, where we focus on building a mini project to apply everything we have learned so far. In this session, we will dive into creating a small web application using either Flask or Django, two popular web frameworks in Python. Let's get started. Today's objective is to take the concepts we have covered in the previous days and put them into practice. By the end of this session, you will have built your own small web application using Flask or Django. This is a great opportunity to consolidate your knowledge of web frameworks and Python while learning how to deploy a fully functional web app. For your mini project, you have the choice of using either Flask or Django depending on your preference or prior experience. Some project ideas include a to-do list app, a personal blog, or even a simple note-taking app. Your goal is to build and deploy a working web application with basic functionality. Let's start with a Flask approach for those who want to work with Flask. First, you will need to install Flask using the command pip install Flask. The typical project structure includes folders for static files like CSS and images, templates for HTML files, and a Python file, usually called app.py, where we define our routes and logic. Now let's look at creating routes in Flask. A route defines the URL pattern that triggers a specific function in your app. For example, you can have a route for the home page, an about page, and even a route for adding tasks to your to-do list. Flask also uses Jinja templating to dynamically render HTML with data from Python. When handling user input, you will need to create forms. Use the request module in Flask to retrieve form data submitted by the user. You can store this data in a simple list or for persistence, a database like SQLite. Once your app is ready, you can run it locally with the command python app.py. If you want to take it in step further, you can deploy your app on platforms like Heroku or Python Anywhere. For those who prefer Django, the setup begins with installing Django using pip install Django. After installation, you will create your project and app using commands like Django admin, start start project, my Django app, and Python manage.py start app to do. Django follows the model view template architecture, which is more structured compared to Flask. Once your project is set up, you can define your models in Django. Models represent the data structure of your app, and Django automatically creates the necessary database tables for you. After creating models, you will run migrations to apply the changes to your database. Next, you will create views that handle the logic and render templates with data. Django also provides a built-in admin interface which allows you to manage your data easily. It's a great tool for administrators or developers to input and modify data without needing to build additional forms. Once you are ready, deploy your Django app on platforms like Heroku or DigitalOcean to make it accessible online. For the mini project, you will need to implement some basic features like CRUD operations, create, read, update, and delete. This will allow you to manage tasks or nodes effectively. You will also need a simple database for storing data, which can be done using SQLite. And remember to design your app to be responsive so it works seamlessly across devices. If you are looking to take your project to the next level, you can implement advanced features such as pagination for displaying large amount of data efficiently, user profiles to personalize the experience, or advanced styling with frameworks like Bootstrap to make your app look professional. Once you have built your app, it's time to review the code. Peer reviews are a great way to get feedback and improve your app's quality. Reflect on any challenges you faced during development and think about areas where you can improve, such as error handling, security, or the overall architecture of your app. When you are satisfied with your mini project, make sure to submit the code along with a brief description of your project. You can also include a video or a live link to your deployed app, which will give others a chance to interact with your project. By completing this mini project, you will have gained valuable experience in web development, including both building and deploying a web application. This is an important milestone in your journey as a developer, and I encourage you to continue exploring advanced web development topics such as APIs, security, and performance optimization. Now, let's open the floor for questions. If you have any doubts about the mini project or any aspect of your web development, feel free to ask. I am here to help clarify any concepts or guide you through any challenges you might be facing.